November 2nd, 2020, in the greenhouse. I was out here earlier and stoked this up a little bit, but I had the air intake dialed back down to basically low idle, and I just threw another chunk of wood on now, and I've opened the air gates up. Guess we'll just look at the chart here quick. And so you can see, I'll shut the headlight off. You can see here where I stoked it up, and you can see where the stove temp went up, and then where I throttled it back. And you can see the temperature ramp down. You can see the thermal mass kind of just hang out. I did tap some heat off to the tank. I topped up that secondary tank. And of course you can see we're down at around 17,000 BTUs in the storage right now, maybe 18,000. And while I was in here this afternoon, I also put the new CPU and other core chip cooler heat sinks on the Raspberry Pi. You can see where I shut it down and brought it back up. You see that low temperature spot there? That was where it was shut off for a few minutes while I did that upgrade. So we should be pretty durable temperature wise now. Of course, there still is the accessory cooling system on here. There's a fan constantly on the processor, and there's a big booster fan to back that up that runs off of processor temp. And then there's a fan here in the box, although I never really seem to get this box closed. I'm always working on something. But when the box is closed, this fan will also provide ventilation. And this is a really nice box by Hyperlink Technologies. I got this off of eBay for I think like 30 bucks, but new these are about 300 and something. They're crazy expensive, but it's got the louvered vents and all, so water can't get in. And I just like it for a box to mount all this hardware in. This box is going to fill up quite a bit as we evolve this whole system forward. Anyway, what I was trying to show you was I'm about to crank the stove up. So I dropped a log on there. You ready? Maybe what I'll do for you as this ramps up, I'm going to stay out here a few minutes and keep an eye on it, and then we'll scale it back to a normal heat production level. But I like to ramp it up good, get the whole stove and chimney hot, burn out the creosote, get all the fire brick and all the thermal mass of the stove up to a good temperature. That keeps a nice clean burn going. Once you do that, you can throttle back. So I like to do that at the beginning of the heating cycle, so to speak. This thermal mass is not all that warm at the moment, sitting around 120, 115, looks like, around there. Anyway, what I'll do, let's see, it is currently 5:36. What I'll do a little later is capture a portion of the chart here, and I'll show you the ramp up speed. Or maybe I'll just take another clip in a little bit, just so you can see how responsive this stove actually is. When you call heat demand, it delivers. So here we are 17 minutes later at 5:53. You can see that thermal mass is climbing rapidly. And the stove temperature is climbing nearly vertical. Very steep climb out in temperature. And let's go have a listen to that stove now. And I can tell you there's a lot of heat starting to come off of this. And we still have the... here, I'll let you listen. And of course that's where the vents open. That's full throttle ahead, so to speak. So that's actually not even full throttle. That's maybe 8th throttle. But what we'll do here shortly is I'll close these vents down, and we'll watch how fast that heat curve continues to climb now that we've got a good draft going and a good coal base. When I throttle these back to a normal burning rate, the heat production will ramp up tremendously. So I'm going to go ahead and do that now, but I got to put on gloves to close these because they're pretty hot at this point. All right. Close them both down all the way. Then we're going to come back half, one, half, half, one, half. That's it. And that's a pretty high burn rate. I rarely go any higher than that. And once I show you how much heat this is producing, I'll probably go back down to something like half on each side. Just a half turn open. It doesn't take much. This stove's a cranker. Alright. Let's go back and take a look at the chart quick. You can see it's 5:56 now. So we're literally 20 minutes from when we started ramping this up. And you can see stove temp is up around 120. Sorry, trying to bounce the headlight back and forth. Stove temp's up around 120. And thermal mass temp is about 128, closing on 130. And you can see we're storing at about 22,500 BTUs in the thermal mass right now. And 20 minutes ago we were down around 18,000. So we've already collected about 4,000 BTUs into that thermal mass. I should mention, while I'm talking about the thermal mass and some of that, so real quick rundown on this. For those who don't know, there's a coil inside of here. For those who've seen this several times, I apologize, but I get a lot of questions on my videos, people who haven't seen other videos. So there's a coil in here. This is the main thermal mass. There's a pump down here in the tank, and that goes through that coil, and we're able to transfer heat from this mass to this mass, or any other place in the greenhouse that we want. We're just transferring to this mass right now. And so this is regulated by a script that's running Python on the Raspberry Pi that takes a look at the temperature here on this sensor and determines what the temperature of the thermal mass is. And normally that script, I'd have sensors in here as well, and that script would compare the difference in temperature between these two. And when the difference is greater than a set limit, I like to keep around 40 degrees Fahrenheit, then it trips the pump on. Right now, because I don't have the extra sensors hooked up because we took a lightning strike this summer, I'm only running a sensor on here to monitor this. So basically have this set to come on at 140 and go back off at 130. I'm probably going to tweak that down a little bit more tonight, because the amount of energy that you can capture from the stove into this thermal mass greatly depends on how cold this thermal mass is. That goes back to part 5 in the greenhouse series, where we talked about delta T and the difference in temperature being a huge factor in how much energy could actually be transferred from one place to another, especially through conductivity, which we're kind of relying on conductivity, radiation, and convection here, where the top of the stove is in contact with the pot for conduction. There's radiation obviously from the top of the stove, and then of course there's convection inside the pot where it's convecting, you know, hot up the center, cooler out the sides, and back down and back in. But so I'm going to tweak that down, but I will show you at some point when I do a stoke. You'll see when I tweak that temperature down, you'll actually see the stove temperature start to drop with it when you reach a certain temp. I find around 125 degrees is about as low as I can go without actually affecting the stove temperature and actually having to change how much air input I let into the stove to throttle it. Really interesting to see how much heat you can actually sink off of the stove. You can actually sink enough to actually crash that burn process, so to speak. Kind of takes it down to a lower level. Anyway, just a few details I thought I would show. I know I've talked about a lot of these pieces, but I thought I would just do this video. This is not actually going to be part of the greenhouse series, I don't think, but just to kind of help people understand how it works and what some of the little more subtle details of it are. All right, I think that's it for now. So here we are at 6:11. So we're about, what, 14 minutes later? About 14 minutes later, and you can see where we kind of started to level out here on the stove temp, and actually you can see it's starting to fall just a hair. But you see this thermal mass temp continues to climb at a pretty steady rate, and so does the BTU value here. And what I'm going to do now, and yeah, this is key too. You notice the greenhouse, excuse me. You notice the greenhouse temperature is now climbing. We'll just follow across here for you so you can see. It's about 66 degrees or so here, and I could feel the difference. You know, in the last couple of minutes in here, it was still a little bit chilly in here, and now I would need to come out of my jacket if I want to stay in here much longer. So interesting to watch those trends. Like I said, I dialed that stove back to 1.5 and 1.5. So now what I'll do is dial it down to 3/4, and then we'll wait a little bit, and I'll show you the chart again. This thing is starting to make, sorry for the camera, this thing is starting to make a pretty good bit of heat in here. And you can see it's actually not even stoked all that well. I really should shake those logs up a little more, but whatever. So now, we'll go all the way in again, back out 1/2, 3/4, 1/2, 3/4. That's it. Make sure our gate's tight. And we'll go back to the chart in a minute here, and we'll monitor what happens. Right, here we are, 6:30. This is about an hour after I started this whole video. You can see stove temp dropping back off, coming back down to a normal operating temperature. For comparison, I'll take you back to last night when our settings were about the same. And so you can see we're going to regulate back here again, just like here. We have nice flat temperature line in the greenhouse, relatively steady heat production, and of course you can see the thermal mass being managed a bit here, and you can see the swing go up in the daytime with the sun radiation and back down as the temperatures cool off. You can see here where the vents open and closed a bit. Where the vents open, you can see the temperature drop dramatically. I probably did not even need to leave that vent script operating today. We wouldn't have gone above a dangerous temperature in here. And then you can see up here the thermal mass is relatively level at this point. So we're producing heat, we're radiating some through the thermal mass, but we're not creating a tremendous amount of excess heat right now. Now this dynamic will change a little bit when I add the coils down under the beds. As I've mentioned before, I'm going to put some kind of coil system underneath this bed here, and I might also do this bed, although I might just use a couple of barrels here as thermal masses. I'm still working out the upgrade details in my head here, plan wise, but that will help. That will take a lot more heat off the system, so we'll actually have to run the throttle of the stove higher to keep up with that initially, until we get all that thermal mass up to temp, and then it'll take less heat to maintain temperatures in here. So anyway, just thought I would do a sort of a walkthrough of, you know, starting the stove up, how that relates to the thermal management stuff I've discussed before, and all that sort of thing. And I think I may make this part 6 of the series, even though it's not really deep explanation. It's a good practical walkthrough of everything I've talked about so far regarding the thermal management. So Just having to be outside looking at upgrading insulation stuff and tightening the greenhouse up for the winter. Turned around and saw the moon rising through the trees. Almost looked like a distant campfire at first. I guess this will be part 6 of the series. Thanks for watching the Pharmacist Seeds Network. Don't forget to like, share, and subscribe. Also, check out my show on Comrades in Farms on Truth Frequency Radio, and also here on YouTube, and now on Spotify and Anchor and a few other podcasts, Google Play, I think. And up and coming soon, my friend Brad from Grow the Farm Up and I are going to open a much deeper discussion. We want to interact directly with consumers and find out what you want to eat and what sort of things you'd like to see in your food supply from the consumer. We want to know exactly what the actual consumer wants to have on their plate, so that we can forward the agricultural system in a way that reflects the consumer's wants and needs. So I hope you'll tune in for that as well. Brad and I are still orchestrating to get all the pieces together for that conversation. That is a very wide and deep, complex conversation. But we hope that you'll give us your feedback and join us in that discussion. Alright, that's it. Thanks for watching the Pharmacist Seeds Network.